What's up, math fans? I'm thinking of two numbers that add up to 10. Guess what the numbers are? Got it? You could say 9 and 1 or 8 and 2 or 7 and 3. You might even start thinking decimals or negatives. But let me make it more specific so it's not so ambiguous. I'm thinking of two numbers that add up to 10, and those same two numbers subtract to give you 4. Now, you don't have as many options. There's actually only one possible set of answers here. What? 7 and 3, okay? In mathematical language or higher vocabulary, I would say the sum of two numbers is 10, and the difference of those same two numbers is 4. What are the numbers? So you set up two equations this time, okay? Because what are we talking about today? Systems of equations using elimination. All right, a system means things going on at the same time. In this case, those things are equations. Two or more equations are a system of equations, and when you have two or more equations, you're gonna have two or more variables. So I got two or more equations going on at the same time. I need to solve at the same time, meaning whatever x and y fits here has to also fit here. Same x, same y. If I change questions now, these two are the same x, but they're not the same from over there. It's a new question. All right, so I'm gonna use something called elimination. Here's why I call it elimination. Some people call it addition. Put a giant plus sign in between. Normally that plus sign won't be there because they're not gonna tell you how to do it. I know to use elimination, and you'll see why in a minute. So I put a giant plus sign, I'm gonna add straight down. X plus x is 2x, y plus negative y. The beauty of those is they're inverses, they're opposites. They will cancel. That's why it's called elimination. Eliminate. Okay, equals 10 plus 4 is 14. Now I just turned a brand new subject into an old school subject, a one-step equation. Hopefully you're masters at the one-step, the two-step equation, equations where you use the distributive property and combining like terms, and any other kind of multi-step equation. Once you're masters at that, this becomes that. So divide by 2, and x equals 7. Done, right? No, be careful, because now I got two letters. I need two answers. I'm going to pick my favorite equation. Favorite equation. You can pick either the first one, which I call line 1, or the second one, which I call line 2. Some people call them equation 1, equation 2. I call them line 1 and line 2 because these actually represent actual lines. But we'll talk about that when we get to graphing. So I'm picking line 1. I write it again to be clear. And then I say, oh, wait, x is 7. Don't write 7. I'm sorry, don't write x, write 7. Oh, look, another one-step equation. Again, new stuff becomes old stuff. Gotta know the old stuff first, okay? Minus 7 on both sides, and y equals 3. X is 7, y is 3, full credit. Some people get really fancy, and they put their answer in terms of a coordinate, x comma y, and they say 7 comma 3. And here is my final answer or solution. Simple as that. Let's practice again. And number 2, I gave a secret away again. I'm going to use elimination. So I put a plus sign here, and I add line 1 plus line 2. X plus x, again, is 2x. That's a coincidence. It's not always that easy. Sometimes there's coefficients. 2y plus negative 2y. Those are also inverses. And eliminate. 8 plus 4 is 12. Divide by 2. X equals 6. Pick my favorite. I'm going to again pick line 1 just because there's a plus sign there. And if x is 6, 6 plus 2y equals 8. Ooh, a two-step equation. Let me subtract 6. 2y equals 8 minus 6 is 2. Divide by 2, and y equals 1. 6 comma 1 would be your next solution. Let's go here. Now, I'm already trained to instinctively put a plus sign here and add straight down. C plus C is 2C. Negative 2D plus 3D, eliminate. Wait, what? No, those don't eliminate. Maybe the C's, they look the same, they should eliminate. If they look the same, they eliminate, but they gotta be opposite signs, they gotta be inverses. These aren't inverses, and these definitely don't matter if they're inverses or not. So I'm stuck. Oh, your magical theory doesn't work. Oh man, video over. Just kidding. The theory works. If these are the same and all you want is inverses, then make them inverses. Negative. So what's going to happen here is, and you don't have to rewrite it, but I'm doing it to be clear. I didn't touch line 1, so I'm going to write line 1 again. Okay? Line 2, I'm just going to change all the signs. You're allowed to do whatever you want as long as you do it to all terms in the equation. So I'm going to, in effect, distribute a negative, also known as a -1, that's a -1, to every term. Changing line 2 to -c, no more plus. Now that's going to change signs to -3d equals -9. All I did was change all the signs. Now I can use my trick. Elimination works. Plus sign, giant plus sign, add straight down. Eliminate. -2d plus -3d is -5d. Okay? And 14 plus -9 is 5. Divide by the coefficient, divide by the coefficient. D equals -1. Go back to the original. You could go back to this original in black also, but I go back to the original here. C minus 2d equals 14. C minus 2 times -1 equals 14. Be careful. I know I kept saying minus, but this is the same as a negative. C, -2 times -1 is +2. C plus 2 is 14. Subtract 2. And C equals 14 minus 2 is 12. So my answer here is -1 comma 12, right? Actually, no, be careful. See how I said put the solution as x comma y? Here, this is not x or y. I'm going to go in alphabetical order, C comma D. So I'm going to say 12 comma -1. I don't know if you can see that, so I'll go here. My solution is 12 comma -1.